The goal of this experiment is to show that Reynolds number is not the only factor when thinking about stopping distance. I'm going to do this by holding the Reynolds number constant for two different objects. However, I'm going to vary their shape. We're going to fire this mushroom shape and this tulip shape. And they both will be fired into water, and the stopping distance will be recorded. Now they are equal mass, they come from the same ping pong ball and darts. Being of equal mass, these two darts should have the same velocity when they leave the same Nerf gun. Now what's interesting about this Nerf gun is that it imparts all the velocity right away. That means that the moment the dart starts leaving the barrel, it's already at maximum velocity. So let's see what happens. We start the experiment by measuring where the dart sits relative to the water line. In this picture we can clearly see that it sits around the 41.5 inch mark. We then fire the dart into the water and measure how far it goes down. From this slow motion video we can tell that it goes just below the water line at 44 inches. We can clearly see from the video that the mushroom shape went down about 3 inches. Next, let's look at the tulip. Again, for the tulip, we follow the same procedure as we did the mushroom. We measure it off to see where it sits relative to the water line, and then fire it into the water, taking the values to find our stopping distance. From this video, we can tell that the tulip shape went down only about 2.5 inches, as opposed to the 3 inches that the mushroom shape went in. So what does this mean? This means that the Reynolds number isn't enough to solely base our stopping distance off of. That instead, we need to also take into account the shape of the different objects.